Hello guys, welcome to our channel Makaut Smashers. Today we discuss about NLP or natural language processing. In previous videos we also discuss about some data science related subject that's about computer vision and deep learning and etc. Now this is time to discuss about NLP or natural language processing. So natural language processing is a field of artificial intelligence that focuses on the interaction between computers and humans using natural languages. The goal of NLP is to enable machines to understand, interpret and generate human-like languages in a way that is both meaningful and contextually relevant. So some key components and tasks within NLP include tokenization, parts of speech tagging, named entity recognition, syntax and parsing, semantic analysis, machine translation, information retrieval, text summarization, sentiment analysis, speech recognition, question answering, and chatbot and conversational agents. So NLP applications are widespread and have practical implication in various industries including customer service, healthcare, finance, education. Advances in machine learning, deep learning and neural networks have significantly contributed to the progress and success of NLP systems. Popular models like BART, GPT, Generative Pre-trained Transformer and others have demonstrated a state-of-the-art performance in various NLP tasks, showcasing the ongoing evolution of the field. So, NLP is a subfield of AI that focuses on the interaction between computers and human languages. It involves the development of algorithms and computational models that enable machines to understand, interpret and generate human-like language. NLP aims to bridge the gap between human communication and computer understanding, allowing machines to effectively process, analyze and respond to natural language input. Some primary goals of NLP including understanding languages, language generation, effective communication. So, understanding language. NLP aims to enable machines to comprehend the nuances, context, and meaning of human language. This involves tasks such as syntactic and semantic analysis, parts of speech tagging, and named entity recognition. Language generation. NLP seeks to empower machines to generate coherent and contextually relevant human-like language. This includes tasks like machine translation, text summarization, and content creation. Effective communication. NLP endeavors to facilitate effective communication between humans and machines. This involves developing chatbots, conversational agents, and systems capable of understanding and responding to user queries in a natural language format. So, we should discuss about some key concepts of NLP. NLP involves several key concepts that form the foundation for understanding and working with human language in a computational context. So, some key concepts at first: tokenization. Definition. Tokenization is a process of breaking down a text into smaller units, such as words or subwords. Importance. It helps in analyzing and processing textual data more effectively. Tokens serve as the basic building blocks for various NLP tasks. Parts of speech tagging or POS. POS tagging involves assigning grammatical categories, example noun, verb, adjective, to each word in a sentence. Importance. POS tagging is crucial for understanding the semantic or syntactic structure of a sentence, which aids in subsequent analysis and interpretation. Named entity recognition or NER. NER is a process of identifying and classifying entities, names of people, location, organizations within a text. Importance. NER is essential for extracting key information from text and it is used in applications such as information retrieval and knowledge extraction. Syntax and parsing. Syntax and parsing involving analyzing the grammatical structure of sentence to understand the relationship between words. Importance. Understanding syntax is critical for comprehending the meaning of sentences and resolving ambiguities in language. Semantic analysis. Semantic analysis focuses on extracting the meaning from a text, including understanding context, intent, and sentiment. Importance. Semantic analysis is vital for interpreting the deeper meaning of language, enabling machines to understand the context in which words and sentences are used. Machine translation. Machine translation involves automatically translating text from one language to another. Importance. Machine translation facilitates communication across language barriers, and is valuable in various applications including global businesses and cross-cultural collaboration. Information retrieval. Information retrieval involves extracting relevant information from a large dataset based on user queries. NLP techniques are used to enhance search engines and information retrieval system, enabling user to find a specific information more efficiently. Text summarization. Text summarization is a process of generating concise and coherent summaries of longer texts. Importance. It is used to extract key information from large volume of text, making it more manageable for users to quickly grasp the main points. Sentimental analysis. Sentiment analysis determines the sentimental expressed in a piece of text, such as positive, negative, or neutral. Importance. Businesses use sentiment analysis to understand the customer opinions, feedback, and public sentiment influencing decision-making processes. Speech recognition. Speech recognition involves converting spoken language into written text. Speech recognition is applied in voice assistants, transcription services, and hands-free computing, improving accessibility and user experiences. So these key concepts collectively contribute to the development of sophisticated NLP system capable of understanding, processing, and generating human-like language in various applications. Advances in these areas have significantly improved the capabilities of language and models and applications in real-world scenarios. Now we should discuss about NLP techniques. Already we discussed about tokenization, streaming and lemmatization, parts of speech tagging, named entity recognition, syntax and parsing, semantic analysis, and now machine translation, automatically translating text from one language to another. Purpose is facilitates cross-language communication and understanding with applications in global businesses and information collaboration or international collaboration. Information retrieval we already discussed, text summarizations, sentiment analysis, speech recognition. Okay. Speech recognition. Converting a spoken English or spoken language into written text. The purpose is to apply it in voice assistants, transcription services, and hands-free computing, improving accessibility and user experience. Word embedding. Representing word as vectors in a continuous vector space. Capture semantic relationships between words, enhancing the performance of various NLP tasks such as language modeling and similarity analysis. Attention mechanism. Focusing on different parts of input data when processing information. Purpose is improves the performance of sequences to sequence tasks such as machine translation and text summarization. Transformer models. Architectures that use self-attention mechanisms for processing sequential data. Purpose: powering state-of-art NLP models like BART, bidirectional encoder representations from transformers, and GPT, generative pre-trained transformer. These techniques, often combined in various ways, contribute to the development of robust NLP system capable of handling diverse language-related tasks. The field of NLP contributes to evolve with ongoing research and advancement in machine learning and deep learning. So now it is time to discuss about the machine learning in NLP. Machine learning play a central role in NLP by providing the tools and techniques necessary for computers to learn from data and improve their ability to understand and generate human language. So at first, supervised learning. In supervised learning, models are trained on label dataset where the input data is paired with corresponding output labels, or annotation on categories. Application in NLP. Many NLP tasks such as sentiment analysis, parts of speech tagging, and named entity recognition use supervised learning. Unsupervised learning. Unsupervised learning involves training models on unlabeled data, allowing them to discover patterns and structure in the data without predefined output labels. Applications. Unsupervised learning is used for tasks like clustering, topic modeling, word embedding generation, where inherent structure in the data are explored. Feature extraction. ML models in NLP often require the extraction of relevant features from the raw text data. Features may include word embedding, syntactic features, or statistical features. Feature extraction is crucial for representing the text in a format suitable for machine learning algorithm, enhancing their ability to learn patterns. Word embedding. Word embedding represents the word as dense vectors in a continuous vector space, capturing semantic relationship between words. Applications in NLP. Word embeddings are used to enhance the representation of words in NLP models, improving their performance in tasks like language modeling, sentiment analysis, and similarity analysis. Also, RNN include LSTM or long short-term memory. LSTMs are a type of RNN designed to address the vanishing gradient problem, allowing them to capture long-term dependencies in sequential data. LSTMs improve the ability of models to understand and generate coherent sequence of text in text, like text summarization and language modeling. CNN, transfer learning, attention mechanism, transformer models also used. So machine learning in NLP continues to evolve with ongoing research focused on developing more advanced models and improving the performance of existing ones. These techniques have enabled significant advancement in the capabilities of language models and their applications across various domains. Now it is time to discuss about NLP models. NLP models can be broadly categorized into three main types based on their underlying methodologies: rule-based model, statistical model, and deep learning models. Rule-based model. Rule-based models rely on explicit, handcrafted linguistic rules to analyze and process natural language. These rules are typically defined by linguistic or domain experts. So, advantages: transparent and interpretable, and effective for tasks with well-defined grammatical structure. Limitation: may struggle with handling the complexity and variability of natural language. Manual rule creation can be time-consuming and may not scale well. Second is statistical models. Statistical models use probabilistic methods to learn patterns and relationships in language based on statistical analysis of large datasets. These models often involve the estimation of probabilities for various linguistic features. Some advantages: can capture statistical regularities in language, more adaptable to variations in language use. So, deep learning models. Deep learning models, particularly neural networks, leverage layered architecture to automatically learn hierarchical representation of language features. They excel in capturing complex patterns and dependencies in data. These categories are not mutually exclusive. Many modern NLP approaches involve a combination of these techniques. For example, hybrid models combine rule-based statistical and deep learning approaches to benefit from the strength of each. This integration is common in systems where rule-based model handles specific linguistic structures, statistical models capture probabilistic patterns, and deep learning models learn intricate features. Transfer learning. Many state-of-the-art NLP models use pre-trained deep learning architectures like BART or GPT on large corporate and then fine-tune them for specific tasks. This approach combines the benefit of unsupervised pre-trained with task-specific adaptation. Okay, so some others like XNet, DigitBART, and Robert and ULMFIT, ELMO, embedding from language models, Transformer XL, GPT, generative pre-trained transformer series, BART, bidirectional encoder representation form transformer. Okay, so this type of models already available in markets, and this model represents a snapshot of the continuous advancement in the field of NLP. Researchers and practitioners are continually developing new models and refining existing ones to address specific challenges and improve their capabilities of language understanding and generation system. Okay, so some applications and importance of NLP. Importance: enhanced user interaction, insight from unstructured data, efficient information retrieval, automation of language related tasks, personalization, decision support, etc. And some applications like chatbot and virtual assistants, information retrieval, sentiment analysis, machine translation, speech recognition, healthcare application, finance and business analytics. Okay, so that in summary, NLP is crucial for making computers more adept in understanding, processing and gathering or generating human language, thereby opening up a wide array of applications across different industries and improving the way humans interact with technology. So, future direction of NLP. The field of NLP is a dynamic and researchers are continuously exploring new directions and challenges. Some of the future direction and trends in NLP include multimodal NLP, explainability and interpretability, low resource languages, robustness and generalization, continual learning, ethical NLP, domain adaptation, casual inference, zero shot and few shot learning, conversational AI, dynamic pre-training, quantum NLP. This future direction highlight the evolving nature of NLP and the ongoing efforts to address emerging challenges and opportunities in the field. Advances in these areas are likely to shape the next generation of NLP models and applications. Okay, so thank you for joining me on this exploration of NLP. We have covered the fundamental concept from tokenization to deep learning models and delved into how machines understand and process human language. If you found this video informative, don't forget to give it a thumbs up and subscribe for more content like this. If you have any questions or topics you have like me to cover in future videos, please leave me in the comments below. NLP is vast and evolving field, so stay curious and keep exploring. Check out the resources in the description for further reading and hands-on projects. Remember, the world of NLP is at your fingertips, waiting for your creativity and innovation. I appreciate your time and interest. Until next time, happy coding, exploring and unlocking the secrets of the language with NLP processing. See you in the next video.